Today we will discuss about torque. So welcome to the video of torque, and this is basically part 2. So today we will be understanding this statement which states that let me underline this. There are two components of torque, right? One is perpendicular to the axis of rotation and another is parallel to the axis of rotation. Now, basically, it states like the basic meaning of this statement is that there are basically two components of torque, one which is perpendicular to the axis of rotation and the one which is parallel to the axis of rotation, right? So in my previous video I discussed that for the torque, for the turning effect, we want that the moment arm and the force must be perpendicular to each other, right? This was the first condition. So now let's look into the second condition, that what else is required for the rotation, right? So let's come over here. Now, for example, okay, this is my moment arm, which is basically R, right? So let's apply the force like this. I'm applying force like this, and basically you have to understand this in 3D, that whenever I apply force vertically, right, it means that it is trying to detach this. It's not trying to move it. It's not trying to rotate the fan, basically. So was here we want, actually we know that, okay, let's parallel shift this R vector, right? It will be something like this, right? And here we have the vector, here we have the angle theta, right? Okay, if we apply the right hand rule, so we will curl our finger from the this moment arm to the force, and we'll get the direction of the torque will be outward. The direction of the torque will be outward. It will be something like this. So this will be the direction of torque. So it means outward. It means the torque will be anti-clockwise, right? And the torque will be positive. Torque will be positive, right over here. So now what is axis of rotation? Basically the point from which the body rotates is known as axis of, so this is basically axis of rotation. And if we parallel shift this torque one vector, we'll find it is something like this, right? Something like this. So basically this is perpendicular to the axis of rotation. This is axis of rotation. I'm writing the short form AOR, which is axis of rotation. Basically the axis of rotation and this torque, like we have parallel shift, this is torque vector which is outward, are perpendicular to each other. So basically we know that the force, the component we have applied is a vertical direction, right? So here the torque will not be produced. The torque will not be produced. Basically here the torque will be equal to, the torque will be, oh, I'm unable to write. The torque will be equal to 0. The torque will be equal to 0 when the force is passing through the pivot point. Line of action of force is passing through the pivot point. Basically over here you can see that the torque that we have applied is in outward direction. So, right, so there will be no torque. The torque produced will be here 0. Or you can see that whenever we apply that when the force is parallel to the, like in a previous video we talked about that when the force was equal to F cos theta, the torque is equal to 0 as the axis of rotation and the F cos theta both are parallel to each other, right? So there will no torque be produced. But when the axis of rotation and the torque are both perpendicular, like let me write over here, axis of rotation is perpendicular to the torque, the torque will be equal to 0. Torque will be equal to 0, right? So here the one is perpendicular to the axis of rotation. This is proof. Now let's prove the one is parallel to the rotation, right? Okay, let's have fan over here. Okay, so here we have our fan. Okay, so here we have our fan. So now let's discuss the component which is parallel to the axis of rotation, right? Okay, so let me draw this. Okay, as we know that this is our axis of rotation, right? And this is our axis of rotation. Let me write over here A O R, which means axis of rotation, right over here. And this is our momentum, which is R, and we are applying our force like this in this direction, right? So the component over here will be like this, which will be F sine theta. Okay, this is our force. Okay, I have applied force over here, and over here let's parallel shift this momentum, and this will be like theta right over here. If from the right hand rule, if we try to find the direction of this, it will be something outward, and it will be in this direction. It will be in it will be in this direction. The tau will be equal to in this direction. So as you can see, the torque, the vector of torque and the axis of rotation both are parallel to this, right? Both are now parallel. both are parallel over here, the axis of rotation and the torque. So here the torque will be produced and the torque will not be equal to 0. The torque will not be equal to 0, right? So basically, like right over here, turning effect will be produced when torque is parallel to AOR, right? And force is perpendicular to the moment arm, right? So the torque will be produced when the axis rotation and the torque both will be parallel to each other. So we know that the here angle we use is sine theta. So the torque will be maximum at 90 degree, right? And it will be minimum at 0 degree, and basically it will be zero at, it will be minimum, or you can say it will be negative at 270 degree, right? So I hope this is clear to you. If any kind of query, you can ask me in the comment section. I'll be very happy to answer you guys.